Welcome back to DevSecOps Talks with Paulina.
And Andrei.
We are missing our third musketeer today.
Yes. And we actually might be even streaming live.
Okay.
Because Matthias is not here and I'm not the best with the Riverside. But
I guess we'll find out after.
We will find out after. I do think we're streaming live. Anyhow, doesn't matter. Doesn't change a thing. The people who are watching now will just see it a little bit earlier. Anyhow, episode 101. And what the best topic for the episode 101 if not infrastructure as code?
Yeah, never dying, always with us.
Yeah, we in fact
still relevant.
Yes, in fact, it was our first episode when we started the podcast, and that was 6 years ago. I think it's good to revisit. I believe we did one revisit, like around episode somewhere in the middle. So maybe episode 50 around that. I think we looked at it. But now with AI changing how things are done, there are a lot of people questioning, should we still do infrastructure as code? And in order to answer that question, we need to go back to the beginning. Like, what is an infrastructure as code? How would you explain that, Paulina?
Definition of your infrastructure in the code, which you can be able to deploy wherever you want. Of course, it needs to, what do you call it? It needs to be specified to whatever provider you're using, wherever you are doing. Is it AWS? Is it other cloud provider? But it's kind of the recipe for your infrastructure. If you can tell it in one sentence.
Yes, so that's kind of haven't changed since 2020. And the way it works is you need to configure something, and that something gives you an API that you can call. And then you are using a tool that can translate your intent written in a text file using whatever the configuration language is there to the API calls and run those API calls towards that provider. In most cases, cloud providers, but it could be also a DNS provider like Cloudflare and so on and so on.
Yeah, but you can also do it for your server configuration very often. There's a bit different tool set, yeah, but it's much more commonly known for the cloud.
This is something that we can debate. So, like the tools like Ansible, Chef, and others, they fall in the category of configuration synchronization. And there are a few critical distinctions I would draw. So one thing is that most of the infrastructure as code tools have is a state. So then when you apply your change, like if you change the spec, you want to implement that spec so that you want to align your spec with the infrastructure, so you want to apply it. Then your tool would do a three-way diff. It will compare what you have on the spec. It will compare what it last seen was written on state, and it will compare what's actually right now on the cloud. And then it will give you a diff and tell you like those things going to change. With configuration synchronization, you're basically SSHing to a server and just repeating the same commands all over again.
Yeah, what I mean more that you have still recipe, which you can be able to deploy, which, I've been in the organizations when they do everything by hand.
Right.
In 2020, so.
No, it is surprisingly so, because like you would think that like the world would be there already, everyone doing infrastructure as code, but also like at 5XL, we just recently moved a couple of customers from manually provisioned infrastructure to the infrastructure as code.
I've also seen quite many years of ClickOps in some of the organizations of the customers, so it's still not quite commonly visible issue. But some people also kind of they want to go away from infrastructure as a code, because I think one of the things they don't like is the keeping state, in sync. They find it quite painful.
Where would you go? Tell me, Paulina. Like, if you're not doing this, is there any better thing?
I'm in the same boat as you. I'm just saying
Okay.
what I'm hearing on the other side. We don't have infrastructure as code because we don't want to deal with keeping state in sync.
Right. I just hope you will just tell us, like, yes, there is a better way, and like, well, apparently not. This is what we have.
We work with right now, at least.
Right. Just to wrap it up a little bit with configuration synchronization. Like a little bit better way of doing it, if your infrastructure allows, is immutable infrastructure. So instead of just running the tool against the same VM or the same server, you use tools like Packer that allows you to build the golden images, and then you deploy those golden images, and you can copy them as much as you like, but you don't change them when you deploy. In order to create a change, you would build a new image and then wipe old ones, deploy new ones. And this way, you ensuring that you don't have configuration drift, which is very prevalent when you do configuration synchronization, because configuration synchronization will touch only a part of the VM that you're managing, but the rest will stay out of any kind of supervision. And if someone logs into that server or VM, does manual changes, you start to have configuration drift accumulating, and as it accumulates, eventually it becomes a snowflake. So something that no one really knows how it came to be a unique thing, and usually it will run the most critical process in the company, and everyone will be very, very afraid of touching it. So that's why immutable infrastructure is much better way of doing it.
But have you seen it being, applied in the correct way? Because from what I'm seeing in more practice is that, still a lot of people have access. There are different environments with different purposes, and it's still, you need to be able to manage infrastructure per environment level very often. Because you also, support different versions of it and so on. I'm not saying it's not doable, but in majority of the cases, I haven't seen it right in practice.
One thing that is missing that we quite often implement for our customers is like a weekly rotation of the VMs, if they're using VMs, trying to move containers like Fargate and stuff. So there are no easy tools to manage because we live in an AWS world. But if there are VMs involved, we're always trying to rotate those weekly. And this way, the only way to do a change is through the Packer configuration. Because if you do anything manually, that's just going to be resetted. And this way, you actually know that your infrastructure is pristine. Like there is no surprises in there. You just continuously discarding the data.
If you're able to do it, because I've seen also a lot of configuration, when, okay, that's my EC2, I don't want to touch it. And even if you need to redeploy it, there's scream test, everyone is coming and screaming around because I've done so many changes manually on my EC2. And I'm not, and I'm not able to get it through, and there is escalating into the management. So of course, in the smaller organization, it's much easier, but in bigger organization, I've seen a lot of drawbacks and hitting the wall around it. If you want to redeploy it,
you humans, what you're gonna do? And that actually brings us to the fact, like, why? Why is it are we doing infrastructure as code? And it is a tool of change, right? So where multiple humans are involved. That's like two important things. Imagine you have your hobby project and you are the only person changing that. Technically, there is no need to do infrastructure as code there because it's only you changing it infrequently. And like if you leave that like Nginx server running, technically nothing gonna happen to it unless someone gets hacked. Like I think yesterday they found some 18 years old Nginx vulnerability. So now everyone is in trouble. Yeah, but technically, like if you don't change it, it's gonna keep running most of the time. So you don't really need to do infrastructure as code in this particular case. I mean, there it will be just a little bit more work for maybe no other benefit since it's just only you changing it, unless like you are infrastructure code fanatic and you're just getting the pleasure of doing that.
I do it in all the side projects, even if it's a small.
Yeah, I mean, like that's our professional deformation.
Yeah.
But like for the normal people, like maybe not. But as soon as you have someone else coming into the project, now you have two people doing ClickOps in a console. How do you know what you have changed?
And who does what?
Who does?
You need to keep logs, and someone deleted the logs.
It's basically the same thing as with a software developer, right? So, like if you are developing alone, you can technically bypass the Git version control system and just work with the local files. It's not advisable, but it would work if you work alone. But as soon as you need to synchronize your changes with other person, you need to have a version control system that like allow us to see the changes, merge them together. The same as with infrastructure. So we're just relying on a well-established pattern of the version control system, like Git, for instance. Like I don't think there is anything else left in 2026, like broadly speaking, and maybe some perforce here and there.
SVN and some other old schoolers.
Yeah, maybe like just waiting for its time to switch. But yeah, I think Git still is the king of the mountain here. Anyhow, that's like the pattern. As soon as you start to get multiple people involved, you need to make sure that the changes are synchronized, they're not conflicting. You need to be able to answer the question who did what and so on. And like with it also opens up the possibility to do all the good things that we do in software development, like code reviews, CI, continuous CIB, continuous integration, CD, continuous delivery, and so on.
That's what I was trying to say next, that, on the moment when you're trying to get another environment also deployed, like, okay, you have one environment and suddenly, let's get production on top of it, or let's add dev or staging or whatever. Then you need to repeat ClickOps from scratch. So if you have it in code, it's gonna take you 1/10 of the time. Of course, you need to deploy it. There might be some bugs and so on, but it's gonna get much faster. In ideal world, you should be able to very easily, but just changing few stuff in the config, being able to reprovision whole environments from scratch. Of course, depending how complex it is, and it might be different complexities or counter dependencies, depending what is it there. But in generic idea is you can get your environment from one place to another in very fast, easy way, changing some few things only.
Yeah, exactly. It gives you a scalability because ClickOps doesn't really scale. And by ClickOps, we are meaning changing stuff in the console, in UI. Just clicking through your infrastructure. Boy, like just thinking about that is painful.
And they keep changing the UI. I almost lost in AWS, okay, that wasn't here a week ago. Now it's somewhere, and they don't change the code as often, or it's much easier to navigate, in my opinion.
Yeah, APIs
are also, that's where we're coming from. So
yeah, API is more stable, but there is also actually like one thing that like people don't talk about. Like infrastructure as code gives you control, a stability, but I would say it's an illusion of control and stability because you are dependent on APIs provided to you. So the magic works while those APIs are stable. Like go ask people who try to do Terraform against Cloudflare provider, which is like changing all the time. Which means that like the stuff you wrote still would work in 1 year. Like it kind of works through the versioning of the providers, but it's also heavily relying on stability of the API behind. As soon as that API changes, your infrastructure as code specification turns into the pumpkin.
Yeah, and on a regular basis, you also need to add that there's also maintenance to it. You need to update your providers. You need to do changes which the providers do, or whatever your cloud provider is doing as well. So there is work even to keep it up, even if you don't use even if you use infrastructure as a code, there is work to put in to being able to get it up to date and secure it.
Yeah. So it is a powerful tool, but it comes with a maintenance. So you have to stay up to date with the changes of API to make sure it still works and gives you the benefits, because it's like with the car, if you don't run it continuously, then it starts to get rusty in some places. So you kind of need to exercise that muscle continuously so it still works, and stay on top of the APIs. Like they're not changing as much, like especially like if you talk about the cloud providers. In most cases, they're maintaining like very stable APIs. So something that worked 2, 3, 5 years ago will still probably work today. So it's not as the biggest problem, but it's more like a philosophical thing, that it's illusion. Like the money is an illusion that we all believe in. Like infrastructure as code is also a mental construct that allows to facilitate the change and communication between the people, so that they don't get pissed off on each other. And then you have other things like compliance. Like if you need to prove people that you are compliant, like infrastructure as code is actually very, very helpful in that regard, because you can quickly show to people how things are done.
And you know what versions are you running, and are you, for example, if there is something introduced, okay, what versions am I running? Did I update it, and so on? So you can very easily have a kind of print screen of your system.
Yes. So moving on, we covered all of that. What's left? I had something.
Is it still relevant?
Yes. So there is a question of the relevance. I guess since it is a tool of change to facilitate communication between people, while people are involved, I guess it is quite relevant. So that's like one thing. Another thing is that it allows you to deterministically argue about your infrastructure, what you got. So it brings a determinism. Like there are people saying, just let agent create it all for you. But would agent be able to reproduce it? No, hold on. No, we will get back. We will get back to it. There are more things. So what we described, that was like a beginning of infrastructure as code, right? So, but over the years, over the last 6 years, we got more concepts into it. So first of all, we got into the situation where we start to, like the infrastructure as code, the movement, like we could say, started with, I think Terraform is like one of the defining tools around it. Like this is where we switched from doing configuration synchronization to actually doing something that resembles the infrastructure as code. It took everyone like who is working operations a little bit of time to catch up with development practices. And as you do more of infrastructure as code, you start to run into multiple problems, like scalability of it, right? So if you work with Terraform, like it's like most widely used tool, so we're using that as example, but it's applicable for the rest of the tools. So if you just put everything in the one humongous repository, that would be really hard and slow to run, because it will do the gazillion of API calls to resolve your state and give you the plan and apply. So that's becoming hard. So people started to split the state, or like those Terraform specs, into smaller pieces and apply those separately. And I do remember, like in 2019, beginning of 2020s, there was like a lot of talk. How do you do that? What is the best mental model of how you slice your infrastructure as code? And the question there is like, it depends. I haven't seen any specification that would like be prevalent. Like there are people doing it all possible shapes and forms, and I would say it really depends on complexities. Like, so for instance, if you're doing multi-account, multi-region, then you would have like one structure. If you just if you have a small project that just lives in one account, one region, you can have a different structure. then like also how you layer the environments on that. So that's like also another thing.
But there's also, I think, one thing to the layering. You have two layers kind of. You have base infrastructure, which you need to be able to run anything, networking, maybe database, if everything, your whole project is based on this, some KMS keys, some stuff like this. So like more base infrastructure. And on top of it, you have, your application, your system. And if you, for example, what I say, if you work in more complex organizations, when you have multiple teams, you have, for example, one team responsible on the base infrastructure, which, everyone takes, they allow everyone else to kind of run. And when you have sliced it by team, for example, or by product, there are different ways of doing it. But I think there are kind of differentiation that you cannot have, only your team or project in the more complex scenarios without having good base infrastructure.
Yes. Yeah, so that's exactly what I'm talking about. Like, how do you slice it and dice it, and how do you structure it? It's quite dependent on the shape and form of organization. And that brings us to the topic I wanted to bring up is emergence of reusable components, like that would be models and Terraforms that were like never intended to be a reusable components in the way they are now. Like talking to people who developed that feature, I think it was Paul mentioning it. But that's what we got now. Now on the internet, you have a huge library available of Terraform models that you can just reuse. And internally, people will have a registry with their primitives for the infrastructure. I think like in CDK world, it's called constructs. And quite often you will have a team maintaining all of that and providing the development organization with those primitives. Those will be a platform team. So the development organization developers, they don't need to, do it from scratch every single time. They just can take some things that already exist and apply that and deploy
so for
their
example,
application.
You wanna add as free buckets, but you wanna ensure it's secure. You wanna ensure it's configuring the same way across whole projects or the system or organization. It depends how it's your organization structure depends. But for example, you have logging that you're using probably encryption for it, that the bucket is not public, and so on, and that you as a developer doesn't need to think about it. You just take the ready module done, maybe, or pointed by your organization, or maybe wrapped up with additional stuff they want you to have there, or they configured in a certain way. You take it, you add, or maybe you need to configure, name and a few stuff, and then you can easily reuse it without thinking what needs to be inside.
Right. Yeah. So as you can see, it's kind of adds up and gets more complex, but that's how it evolved. And in, I think, most recent version of the infrastructure as code book, what they introduced as a concept was stacks. That would be like, how do you put it? Like the pieces of the infrastructure or like application that you put together, and then you can deploy it multiple times. So we moved from just one big state describing everything to then slicing that into models, adding environments, and now we're adding stacks as deployable units. Like that would be maybe your networking stack, saying like you deploy it in development, staging, production, or whatever names you prefer for the environments. So the concepts are evolving in infrastructure as code. So like those concepts, they did not exist when we spoke about that in 2020. So the platform engineering emerged, the idea of stacks, and most of the infrastructure as code tools today have this concept in one way or another, like of stacks, that you can apply to your infrastructure. I think that would wrap up our overview of it. I mean, there is obviously like GitOps and all that stuff that happens in the Kubernetes land, but no need to be too preoccupied about that, because it's like just instead of you applying the infrastructure as code or UCI, applying infrastructure as code towards the APIs of whatever provider you have, you would just have some server that listens to the to listen to the webhook on your Git server. If there is something new, it will pull and apply. Pretty much working as your CI server. So it's just like maybe a fancy way of calling it something else. It just has like some, it's mostly in Kubernetes world, I would say. So there is like stuff like Ergo CD that's being used to automatically deploy stuff to Kubernetes when you push to the Git repository. The only difference here is like the biggest difference here is the fact that the entity that does a deployment resides inside your Kubernetes cluster and pulls changes into your Kubernetes cluster and applies them there. Compared to CI being outside of your Kubernetes cluster and needing access to the control plane API. So you need to expose a control plane API to your CI server. If your CI server is a public CI server like GitHub Actions, that might become problematic unless you're running the private workers. So in that sense, actually GitOps makes a little bit more sense because it makes things easier if you need to deploy to Kubernetes. So then you don't need to expose the Kubernetes API to the outside world. So the rest of your CI could run on the public runners, but the actual apply will happen by the entity residing inside the cluster. So there is no need for the outside access to the cluster. That's kind of useful. And there was another tool called Crossplane. I think there might be more of them nowadays. I mean, like I'm not too deep in the Kubernetes, but Crossplane kind of does the same as Terraform. I don't think it gained a huge adoption, but at least I haven't.
I know some organizations which using it quite widely. So
yeah, it's kind of used here and there, but like it's not a go-to tool, I would say.
no.
That could call the APIs, like the cloud APIs for you. So it would call, like you would have the YAMLs, like the Kubernetes manifests, and that will apply those YAMLs towards the AWS. So it might create S3 bucket. And I've seen that going wrong horribly because the way Kubernetes works, those are Kubernetes manifest, Kubernetes continuously trying to reconcile its state. So talking about keeping state, continuously updated, that's what Kubernetes does. And some of the AWS primitives, like S3, charge you for API access. So if it gets like very insistent, there is like the timeouts and that you can configure. So it's not doing it very frequently. But I saw the situations where it had a conflict. It was like trying to delete bucket, not succeeding, and wrecking quite a bit of API builds. Just like hammering that bucket with a API request. Like, is it still there? Trying to delete. Is it still there? Trying to delete, and so on and so on. So not ideal. Like, probably they fixed it because like last time I worked with that was like 5 years ago. Maybe it's better now. But that's just something that you need to be aware.
Yeah, depending on what you're running, is it Kubernetes or not, or how your infrastructure looks like, there might be different set of stuff a bit you need to look into.
One of the latest advancements in infrastructure is Codeland, is something that's called, I believe, state graph.
Oh, and we also didn't mention big breakup with OpenTofu.
Yeah, there was that. We mentioned that in our last episode, in 100th episode. So like this transformation of HashiCorp, now it's actually came the full loop because like both co-founders left. Like the first was only Hashimoto leaving. Now Arman also left. So like now that HashiCorp is very well in IBM hands, and they even actually doing some integrations with Ansible now with Terraform. So, I think someone like coined the terrible, like where you put together Ansible and Terraform. This is, I think, this
sounds like
that was a joke.
Kind of.
That was a joke, but it's now happening. There was like a bunch of tools who tried to reinvent it. We mentioned last time Pulumi. There was a breakup, like OpenTofu going public, like open source, like true open source, not PSL. I think they brought some innovation. They actually pushed some innovation into Terraform because Terraform was quite stagnant. Now they have a reason to move. Competition is good. But like the state graph, if you look it up, called better control plane for Terraform, the basically idea is that you use a database instead of S3. And then it's represented as a graph, and you can actually calculate your plans much faster. So that's like interesting idea, which could be very helpful for the big states and the big infrastructures, like where it is becoming a problem. There is like another term that emerged, I think, during the last 2 years, like Terralit, where you just have a humongous Terraform state, which is like really hard to manage. There is that. And people now being advised to slice it because just tool cannot cope with it, but like actually state graph might be able to do it for you.
I think we'll wait and see what can we get out of it.
Yes, but now going back to the relevancy. So yeah, agentic AI is there. It could write your Terraform with some level of success. It could also call the cloud API with some level of success. But as I mentioned, it's not deterministic. So I think Paul and Co with a Swamp tool trying to change that. They're trying to make it more deterministic. We'll see. Maybe that will work. I mean, obviously the agents are very, very helpful in writing infrastructure as code nowadays. But I still do think that it's will be there at least for now while humans are involved in the process. Because like
what we see, how people go with public buckets, public databases, for some time we're around.
Yes. And I believe what might happen that might obviate a need of it at some point is if cloud providers move from API-based provisioning to something else. So if the underlying foundation would change, or humans don't need to be involved in the process, that's like one. But if else underlying foundation is changing, then there probably will be a big change into it. By this, I mean that we today have basically two ways of configuring cloud infrastructure. So we have APIs, which are super flexible, and then UI for mostly, I think it's mostly for viewing, but like the people who are just starting up, they would probably still do configuration through the UI. So if the cloud provider to give you a way of, I don't know, giving you YAML, or you providing a YAML to the cloud provider instead of calling APIs, and then cloud provider doing what cross-playing is doing, reconciling that YAML and keeping it in line, like keeping what cloud infrastructure has in line with your intent. So you state your intent, and then cloud provider itself aligns the infrastructure with your intent. That probably will obviate the need for the infrastructure as code in the state we know it, like with the tools we use today.
But it might change to some way, usually in every big change, something new is evolving. That's what I learned. So we might not know how it's gonna look yet. So, okay, infrastructure as code might go away, but you still need kind of way to being able to figure out what's going on there.
Yeah, that's what I'm saying. You just provide the cloud provider your intent. So basically, you like right now, the infrastructure as code is acting as an intermediate.
You have more steps in between. Yeah.
Yeah, because cloud provider doesn't give you that opportunity. So if they would have something in between in the cloud itself that can do it for you, not cloud formation, Well, cloud formation is kind of step in that direction, but like better. Then, yeah, well, I mean, like, it's not too bad. It's not too horrible, I should say. Like, it has its minuses, but it's quite useful in some cases. Like if you do like the account vending, then having the stack sets, cloud formation stack sets, is actually much more useful comparing to just going applying Terraform on every account. You can still do that with IFT, but yeah, a story for another time. Yeah, 2026, we still think that you should be doing infrastructure as code and paying attention to it. Like that's our belief. Actually, one thing that might obviate it also, if you look at like startups, what they do, right? So you have like railway.com, well, used to have Heroku, I'm not sure if it's still around. You have like Neon providing you databases. So you have those like neo cloud providers that give you an ease of configuring, where like the clicks ops like really is not a problem. Like as DigitalOcean started one day, it was like very simple. If we can figure out something like this, like it's very simple to configure and it's easy to maintain the cohesion, yeah, then maybe we don't need it. Like because it looks like every simple solution we get eventually gets the feature creep and it just becomes more complex, and so on and so on.
It's too overcomplicated to being able to manage it and so on.
Yeah, I don't mind as a consultant. That's kind of
no. I don't mind. From our point of view, we're coming as an external usually and getting quite good money out of it for being expert in something. But from the company point of view, yeah, it's a bit different talk.
We wish there would be a better way, but that's the way we have today. All right. With that, I think it's time to wrap up. We will see where the whole infrastructure as code movement in a couple of years. Maybe it will be very different in 2-3 years, but for now, it is where it is.
Let's see. I don't know. It's usually the speed up is not linear. Once it happens, it's probably boom. Probably within a few months, everyone's gonna be changing. So
yes. All right. Thank you for tuning in.
Thank you.
Thank you for watching live. If you did, bye-bye.
You have been listened to DevSecOps Talks with Matthias, Andre, and Paulina. For notes and information, please visit devsecops.fm. Thanks for tuning in.